Alright, we're in 11.7, which is series strategy, and we have directions of state whether the series is convergent or divergent, and support your claim with any work shown and state any test that you use. In other words, don't just write convergent or divergent and move on. You got to have some work shown here, and a lot of times that involves using at least one test, which is on a formula sheet. So in this section you should be using your formula sheet for exam 3, and then I also have a series strategy sheet to help you, although that is not given on quizzes and tests. So here we go, we got this example of the series, infinite series from n equals 1, and we have negative 1 to the n times 3 over 4n plus 1. So we're looking at this and we have all sorts of possibilities in front of us. One thing you might notice is that it's alternating. And that was section 11.6. Just kidding, 11.5. And so when we have alternating series, maybe you're going to use alternating series test. Which is again on the formula sheet. Another possibility that came up a lot in that section for alternating series is if it's divergent, a lot of times the divergence test was something that came up because the alternating series test can't be used to show divergence. So also note that for alternating series now, kind of looking back at some other possibilities, that because it's alternating we can't use integral test. The p-test isn't going to apply, direct comparison, limit comparison, not directly. I mean, there's some things you could do with regards to absolute convergence with those, but you know, pretty much those are straight up not going to be things that apply. So looking at this, you might be thinking the alternating series test applies here because it looks like, well, first of all, in terms of the divergence test, looking at the limit as n goes to infinity, what we'd have for this is 0 for the a sub n, so that divergence test doesn't apply here. Anyway, I'm going to commit to spending some real time now on the alternating series test. So I'm spending some time deliberating on what to do here. Make sure you don't get too bogged down in the beginning. You know, if it's an alternating series, why don't you try the alternating series test unless it's obviously divergent or something. So the alternating series test has our infinite series broken down into the alternating part times like this b sub n thing. And so our b sub n is 3 over 4n plus 1. And so one of the first things is to verify that b sub n is greater than 0. Again, this is all in the formula sheet. And it's not usually something that you necessarily have to show. It's just something you got to make sure is happening, or else you can't, the alternating series test is conditions not being met, and you might make a false conclusion. So notice for n greater or equal to 1 that certainly b sub n is greater than 0. So no issues there. Next thing, b sub n, we need to figure out if it's decreasing. So looking here, if you have time to show it by showing that b sub n plus 1 is greater, just kidding, less than or equal to b sub n, then go ahead and do it. But on a quiz or a test, as long as you're making some argument or showing something for a particular n that it is getting smaller each time, that's probably going to be good enough. And it's hard to be too, I'm sorry I'm being wishy-washy here, but it really kind of depends on the context. So anyway, I got time. I'm going to go ahead and show this, plugging in n plus 1. And I guess I'll throw out the equal. It can be kind of a little bit sloppy with that, but make it legit. So here is the b sub n plus 1 less than b sub n, and then the algebra involved here is to go ahead and multiply both sides, clear the fractions. So we're going to have 3 times quantity 4n plus 1 is less than 3 times 4n plus 1 quantity plus 1. So going from here, I'm just going to go ahead and break this up. 12n plus 3, and then I'm going to have 12n plus 12 plus 3, doing some mega distributing there. 12n, those cancel, so why not just do that now? Then I had 3 is less than 12 plus 3, which of course is true for all n. Okay, but it only has to be n greater or equal to 1. So what I just showed is that b sub n is decreasing. Alright, the last thing is the limit as n goes to infinity of b sub n has got to be 0. So let's do it. We got the limit as n goes to infinity of 3 over 4n plus 1, and that's a real easy limit. It's 0. And so we got our 3 conditions for the alternating series test, so we can conclude that our original series, have that alternating business in there, is convergent. And so I stated it up above with the alternating series test, but maybe you try a different thing or whatever. So I just try to get in the habit of committing to the test that I use with my answer. Okay, that's it for that one.